Hello, so we like to look at some questions from the review questions for the coming exam. Alright, so let's look at number 2 first here. How many points are equidistant from two intersecting lines? Since we are looking at two intersecting lines, first I'm going to try to draw two intersecting lines. Alright, so these are the intersecting lines here. And then equidistance from these two lines, then we are looking at, if I were to use the green line to describe it, it would have been something like this. Right over here. And then another one would have been something along this way. So here we have, we get to realize this angle must be equal to this angle, so as this angle must be equal to the other angle. We end up getting the angle bisectors. Now, 3 units from their point of intersections, a given distance away from the point, then we are looking at the circle. So given that this portion is 3 units apart from the intersection, then how many points will satisfy those two conditions? So once again, I'm going to express all the loci as a green. Yep, no fill. Maybe lines. Alright, then here we're going to have 1 point, 2 points, 3 points, 4 points. So therefore, our answer will be choice 4. Alright, so let's look at the next question here. In a given plane, P is a point on the line L. So let's look at line L here. Let us say this is a line L going the other way also. Now, P is somewhere here, let us say. Now, consider the locus of points in the plane 3 units from the line L. So 3 units from the line L, then what we can do is let us assume that this is about 3 units this way. So is this way. Okay. Alright, then in this case, and then locus of points in the plane h units from point P. Now, so then since we are looking at particular distance away from a point, that means we will be drawing a circle. So once again, I'll be drawing a circle in green. Here we have. So first, what if h is equal to 1? That means it's going to be around here, because if you think about it, if this is 3 units, it has to be about 1/3 of that. So in this case, we will have 0 number of points. There will be the intersection of the two loci. What if h is equal to 3? Alright, then in that case, now we're going to be looking at 3 units, but then it will be just about this way, because radius is 3 and then separation between the dotted line and then given line is 3, 2. That means how many intersections would you have? 2, right over here. Now how about 3.6? If it's a 3.6, then what's going to be happening is this. We will get another. This is up to 3, but we have to go a bit further, 3.6. That tells us that the intersection would have been right over here, 1, 2, 3, 4. Just to be clear, this one doesn't exist, this one doesn't exist. Right, so we have 4 points. So 4 will be our answer. Alright, number 10. Here we have 2 trees that are 40 feet apart. Now, lampposts, so that the posts are 30 feet from both trees. 30 feet from both trees, that means, let us try to draw a circle here. So this is about midway, that means 20. We have to go 30, that means it's going to be more than that. So is this. This will be about 20. Let's go a bit more than that. So this will be about 30. That tells us that points of intersection will be right over here. The other one is up there. So how many lampposts are possible? 2. 2 locations are possible. Alright, number 11. One thing about tangent line segment and then a circle is that it's always equal to each other. In other words, BT must be equal to CT. And then SA must be equal to SB, and finally, RA must be equal to RC. That's what we get to realize. Then, here let's look at it. Since this is 3, this must be 3. This is 5, therefore this must be 5. But the whole thing was 13 between RT. Given that this portion is 5, then this green is 8. Then the question is, what is RS? So since this is 8, therefore this must be 8. Because two tangent line segments are equal to each other. Then 8 plus 3, total entire thing becomes 11. That becomes our answer. Alright, I'll see you later. Bye.